First one isn't too bad. This is not really a lot of application, but it's strictly a mathematical type question of find the equation for a line tangent to the curve that has the largest slope. What does the curve look like? Start down and finish up, or start up and finish down? So if you think about the graph, and the question is, where is the slope the largest, or in other words, on a number line, where does it have the value greatest to the right? Okay. So you tell me when you think I reach a spot where I have the value that is the largest for the slope. Yeah, because you can see that this is a negative slope. This is negative slope, and here seems to be where it would turn most positive, so to speak, right? And so you would think that it was, and you already identified the point of inflection where it changes concavity. That seems to be where it would occur. Well, let's show that that's where it occurs. It says the largest slope. In other words, we want to maximize the slope. So we need an equation for slope. Well, if this is the function, what do we do to come up with an equation for slope? The derivative tells the slope, right? So your slope function is 2 minus 12x minus 3x squared. Well, what do we want to do with the slope? We want to maximize it. How do you maximize something? You take the derivative and set it equal to 0. So we're going to take the derivative. So the derivative of the slope is negative 12 minus 6x. We'll set that equal to 0 and solve. 0 equals negative 12 minus 6x. What would x be? What does that mean? Good. So if I have my point on my line, Michael's just identified that that point is negative 2. But it says to write an equation for a line. So I have my point on my line. I know the x value is negative 2. How would I generate the y value? To the very first equation, right? So that would give me a negative 4 minus 24 plus 8. Because it's going to be negative 2 cubed, it will be a negative 8, and then minus the negative will be plus. So we got negative 20. And then how would I come up with my slope? Plug in negative 2 to the slope formula. So I have 2 plus 24 minus 12. Or 26 minus 12 is 14. So that told me the slope. That told me the location of the point. So now I write my equation for my line. So y plus 20 is equal to 14 times x plus 2. Well, y equals 14x. That'll be plus 28, and minus 20 will be plus 8. There we go. Not too bad, huh? How about number 8? This one will give you a run for your money. Tried to set you up with some kind of things to help you out a little bit last year with this type of problem. We'll see if we can make any progress with it. It says find the equation for a line through the point 4, 2 that cuts off a triangle from the first quadrant with the smallest area. So that sounds confusing. So just to kind of make it somewhat understandable for us, we'll draw a picture. It goes through 4, 2. And it says it the line goes through 4, 2, and it cuts off a triangle. So this is your triangle. And it says we want the smallest area. We're trying to minimize the area of that triangle. Well, to find an equation for a line, okay, we need slope, and we need a point on the line, right? Do we know either of those? Point on the line is 4, 2. Do we know the slope? We have no idea. We're going to have to figure that out. What's driving the problem is the smallest area, right? So that's the equation I'm going to write down. Okay. Smallest area. What is the area of a triangle? Good. Now I'm going to call this the base. I'm going to call this the height. So this is where the trick comes in. And I remember I was, flipping through these problems a few years ago, and I encountered this one. I was like, oh, I wonder how this one works out, and I did it. I really liked it. And so I did it with my first calculus group, and I tried to see how they liked it. And their response was, it is absurd, Mr. Gens, that you would think that we could actually do that kind of a problem. But what was really cool is when they got to the test, they did it quite well. So at first you're going to look at this, you're going to kind of think it's impossible, but it's really not that bad. Okay, you have a problem like the center assignment, you'll figure it out, trust me. So we got 1/2 base times height. What's drawing me to some interest here is that there's coordinates. So instead of just labeling this B, I'm going to talk about this spot right here as a coordinate. I'm going to call it B0. Does that make sense? So then what would this coordinate be right here? Yeah, 0H. So in other words, the x-intercept is going to be the base. The y-intercept is going to be the height. All agreed there? So we need to write an expression for the base, and we need to write an expression for the height. And our expression really starts from the fact that the base, or the x-intercept, we know has a relationship to the point 4, 2. So I'm going to write an equation for a line, y minus y1 equals m times x minus x1. And the reason why I really like this type of a setup is, in the end, I need to figure out slope. And does this have slope in it? Yeah, it sure does. Now, what part of this do we already know? Yeah, so I have y minus 2 is equal to m times x minus 4. Now, if I want to write an expression for b, what could I plug in for y and for x? B0. I'd plug in b for x and 0 for... And so if I did that, I would get negative 2 equals m times b minus 4. Solve for b, because we want to know what b is equal to. We got to put something in for b. Solve for b, and we get negative 2 over m is equal to b minus 4. And then add the 4 to both sides. 4 minus 2 over m is equal to b. Awesome. So far, if you look at what I have area, and what's our new variable going to be? Not b, but m. Area in terms of m so far is equal to, we have 1/2, and what do we put in place of b? 4 minus 2 over m. Yeah, I'm going to do the same one for h. And I have the same thing here, y minus 2 equals m times x minus 4. Okay? But instead of plugging in b0, I'm going to plug in 0h. So what goes in for y? So I have h minus 2 is equal to m times negative 4. Or h minus 2 is equal to negative 4m. How do I solve for h? And we're just going to add 2, so h is equal to 2 minus 4m. Yep, it's okay. So it's tough to see that the problem sets up like this from the beginning, isn't it? But it's really nice when you think about it. We want to find the slope, and we wrote an expression for area in terms of the slope. And so it's come to work out quite nicely here. So would you like to take the derivative right now, or should we multiply it out? Okay, let's multiply it out. This is where we start to have maybe more fun. So we got 1/2 times 4 times 2, 8. Good job. Sorry. We all get confused with mental math this time of year, right? It's like you can do calculus, but you can't do multiplication. It's just kind of like those. So we got 4 times negative 4m. All right, we're on a roll. And then we've got negative 2 over m times 2. We got negative 4 over m. We'll see if you can get this one. Negative 2 over m times negative 4m. Good job. Because the m's cancel. Wanted to cut people off at the right time. So good job. Yep, so we got that 8. So we're gonna we got area in terms of m is 1/2 times, combine some like terms, 16 m minus, I'm gonna write 4m to the negative 1 because I know I'm gonna have to take the derivative, and that might be more helpful to write it like that so we don't get all confused. Could I distribute the 1/2? Yeah, so area in terms of m is 8 minus 8m minus 2m to the negative 1. Just take the derivative. I mean, you guys understand how awesome that is? It's like, try to maximize it. Well, how in the heck do you maximize something? Take the derivative. I mean, it's like, wow, okay. I guess that's pretty cool. No big deal. And we set equal to 0. What's the derivative? Yep, 2 over m squared, right? You solve by either adding the 8 and cross multiplying, or you can find common denominators. It doesn't matter. 8 equals 2 over m squared. Cross multiplied, 2 is equal to 8m squared. Or 1/4 is equal to m squared. So what is m? Look at your figure. Is it going to be a positive slope or a negative slope? Negative. Do we now have enough information to write our equation for our line? We sure do. Y minus 2 equals negative 1/2 times x minus 4. Negative 1/2 x plus 4. Isn't that awesome? All right, let's get into more of the kind of the yard barbers type. We'll figure it out. So when you bend it, what shape is it going to make? It's going to make a trapezoid, yeah. Okay. Okay, all right. Very good, thank you. Okay, now obviously the gutter doesn't have a top to it, okay, unless you decide by like a leaf guard or something like that. But the idea is that we have an angle that we're going to bend this with, okay? It's 10 centimeters on the bottom, and each side is 10 centimeters as well. That's up to you. I'm not going to do a box for this one because we're going to be kind of free floating here. Oh, okay. I'm sorry. I just did the problem from your assignment. You're absolutely right. This problem says 7 and 10. Okay, my bad. Okay. Sorry about that. Okay. So what's driving the problem? Yeah, so we need the area of the trapezoid, right? What's the area of a trapezoid? Yep, times the height. 1/2 times the height times b1 plus b2. Now, this is going to be a little tricky. We've got to get theta into the problem somehow. I'm going to continue to kind of draw some shapes in here that will help us out. Got some triangles now. I know that this dimension is 10, right? We're going to call this h, and we're going to call this x, and that will be the same over there. That'll be x. So now I have a is equal to 1/2 times the height. Do we know the height? No. What's base 1? 10. What's base 2? 10 plus 2x. So really I have area is equal to 1/2 times the height times 20 plus 2x. I could multiply by the 1/2. I get area is equal to h times 10 plus x. Good with that? Now, remember, in the previous problem, this is not easy to do. I mean, this is definitely a sign of a more astute mathematician. In this type of a problem, what we need to find out is we needed to find out m, right? So I wrote out the area in terms of m. So it was hard to see how that would come up with the problem when we started, but we ended up with area in terms of m. Here we want the area in terms of what? Theta. We want to figure out theta. So I need to get rid of the x and the h, and I need to put theta into there. Now, I don't like that angle so much as I like dealing with this angle. We're going to call that alpha. Yep, it would be 90. It would be 90. So once we figure out alpha, we can subtract it from 90, and that would give us theta, right? Well, that depends. You know, you do have your Hainers, and so you get to decide how you're going to fasten them. There's all sorts of different brackets that they make as well. So, and some people, you're right, in some situations they do have a fascia board that is, perpendicular to the ground. But some houses have a fascia board that are tilted as well. So, you're right, you do have an 1.5 inches for drip edge, and then you do have an extra 1/2 inch for your shingles as well. Okay, but so all this needs to be taken into consideration. Okay. Yep, leaves and soot and everything else. Thank you. All right. So, all right. So let's push along with it. Dirt. All right. All right. Here we go. So what I need to do is I want to focus on x. Okay. Tell me which trig function comes to mind for you if I focus on alpha, 7, and x. Sine. Thank you. Sine of alpha is equal to what? X over 7. Very good. See how I've now introduced alpha into the problem? Can I solve for x? Yeah, 7 sine of alpha is equal to x. Hey, I got to get rid of h. Which trigonometric function comes to mind if you say alpha, 7, and h? Cosine. The cosine of alpha is equal to h over 7. So therefore, 7 cosine of alpha is equal to h. One sine and one's cosine. So I now have the area is equal to, h is 7 cosine of alpha times 10 plus sine of alpha. Whoops, sorry. So look at what we have. We have the area now in terms of alpha. I mean, that's a pretty cool thing, isn't it? We just got rid of our x's, our h's, anything else, and we have alpha involved. If we want to maximize the area, what do? Take the derivative and set it equal to? In order to take this derivative, what rule do I have to use? Periodic. Very good. What's the derivative of 7 cosine of alpha? Negative 7 sine of alpha times 10 plus 7 sine of alpha. Now I need the derivative of 10 plus 7 sine of alpha, 7 cosine of alpha, times 7 cosine of alpha. And we get 0 is equal to negative 70 sine of alpha minus 49 sine squared of alpha plus 49 cosine squared of alpha. We're pretty close to finishing this off. I don't know about you guys, but last year when I did trigonometry with you, I had a tough time solving trigonometric equations that had both sine and cosine in them. I really don't. I know exactly what to do. I'm afraid you guys don't know what to do. Yeah. You could take out a 7. That's not going to help us a whole lot because at the end of the day, we have this cosine. And I need to get rid of the cosine. What do I substitute in for cosine squared? Somebody please help me out. Very good. I will make that trigonometric substitution. And I get 0 equals negative 70 sine of alpha minus 49 sine squared of alpha plus 49 minus sine squared of alpha. Can I combine some like terms? 0 equals negative 49, negative 49. Negative 98 sine squared of alpha. Those two are gone. Minus 70 sine of alpha. Plus 49. Sweet. We know how to solve that. Quadratic formula, right? No big deal. Who's got it on their calculator? 4 minutes, 2 seconds. I made it for you. Somebody said they didn't have time to do that, and I challenge the person that they waste more time than that to give a day every day. What do you got, Jake? You're a loser. What do you got, Jill? Got negative 98, negative 70, and 49. Type them in. That's good. And then point. Okay. Let's look at what we got. Now, normally when we do this, we get x equals negative 1 and x equals 0.4. But instead of x, what do we have in its place? We have sine of alpha, right? We don't just have alpha, we have sine of alpha is equal to negative 1.149, and sine of alpha is equal to 0.435. What's the biggest value that sine can be? What's the smallest it can be? Negative 1. So can sine ever be negative 1.149? Disregard. Now let's think of our construction people on the ground. Do you think that they're going to want this answer in radians or degrees? So, B. Rhodey wants to work in radians, but most construction people, surprised or not, they would actually like to work in degrees. And so this is the one time in calculus that you're going to work in degrees instead of radians. All other times you're going to work in radians, okay? So we go sine inverse of 0.435, and I get 25.79. So let's see if we can answer the problem. If alpha is 25.79, what would I do to figure out theta? Subtract from 90. So 90 minus the answer and I get 64.21 degrees. I took sine inverse. Now, did you use geometry in solving this problem? Did you use algebra? Did you use the quadratic formula? Did you use trigonometry? Did you use calculus? Part of the reason I love this problem, part of the reason why I put it in here is so that you understand the collection of mathematics that you've accrued over the years and how you can use it. So that problem, you do have one in your assignment like it. Fortunately, the problem, it works out quite nicely. I have it all worked out for you on the answer key. The answer key is done, except I know I made a mistake on the very last challenge problem. I'm trying to work that out. Question.